Quick lesson on graphing from some data tables that we might have collected for a lab report. We'll have graphs required in many of our different lab reports. So for this particular graph, I want to graph the object distance, or 1 over the object distance, versus 1 over the image distance. Now, one thing to think about, we're going to take these two columns and create a graph. Think about this as the x and this as the y-axis. So when you're graphing two columns of data, the first set of values is going to be typically, by default, your horizontal axis, and the y is going to be your vertical axis. So we say that the x is the independent variable and the y is the dependent variable. So when you're going to do a graph, make sure you include the header as part of your graph, because that will help Sheets, when it does a graph, create the axis labels. So let's go ahead and do that. Now I'm going to select those two columns, and I'm going to go Insert, Chart, and I get this funny looking graph that doesn't make any sense. And I'll say that the critical thing here now is choosing the type of chart. We will always in this class be choosing an XY scatter plot. So this is the scatter graph. We'll choose that one, and that looks a lot better. So now we have some data points that look to be kind of lining up here. So that looks really good. Now, what this thing is missing is axis labels. So we're going to do some customization here. And this is standard. You're going to want to do these for all of your graphs. So your chart style is always going to be a scatter graph. And then when you get to the chart and axis labels, your chart title, in this case, this looks like it's going to be, well, we have the object distance is, let's say 1 over the object distance is going to be on the x-axis. So we'll say we'll call it, where's my chart title? We'll say 1 over image distance, because that's going to be the vertical axis, versus 1 over the object distance. So when we're labeling our graph, we have the vertical axis versus the horizontal axis. Okay, so that looks good. And then we want to do we've got the chart title, we want to get the horizontal axis. And the horizontal axis we decided was 1 over the object distance. And we always make sure we include units in our axis label. So that's going to be 1 over meters. And then we want to do our vertical axis. So it's going to be 1 over the image distance, and that's going to be 1 over the meters. So that looks really good. Take a look at my graph. Yeah, looks great. Okay, next thing. So we got our axis labels. We can close that up. Series. So whenever we do a graph of data for any lab, you will always need to create a trend line or a best fit curve. It's in a curve that kind of averages all of your data. So we're going to click trend line, and look at that. Magically, it comes up with a line that matches all of the data points. In this case, the default is to come up with a linear curve. And in this case, linear is correct. So, but if you tried other ones, you'd get things like this. And you notice how the curve doesn't really match the data? It kind of comes close. You can do a polynomial. You can do a logarithmic or a power series, okay? So in this particular case, linear was correct. And normally you're going to be familiar with the formulas to know if it should be a linear graph or a power graph or what it should be. So you want to think about it before you just go ahead and put the trend line on there. So there we got our best fit curve. The other thing you have to include whenever you do a best fit curve is the equation of that formula. So in this case, it's going to be a line. It's linear. So we say use equation. And this is the equation for your line. And it turns out, in this particular lab, this optics lab, that this is a y equals mx plus b. So y equals m is negative 1.029. That's the slope. Okay, it's a negative 1. And b is where it crosses the y-axis, is 9.2. And it turns out that 9.2 is the focal length of this particular lens whose data we've collected. So that would become important if you're writing this up, to say that b value represents the focal length. Okay, so this graph is now ready to be copied copy with your Apple C or Command C or Control C and paste that into your document. The really cool thing about pasting it into a Google Doc is that if you have to change your data or make a correction, then when you go and play with the graph that's in your Google Doc, you just hit a little update button and it will update with any errors, so you don't have to recopy and repaste it. Okay? All right, so that's done for that one. I would probably typically take this and move it over. Move it over. There we go. So that looks good. I might even shrink it down a little. Okay, let's take the next set of data. All right, so now we have mass versus acceleration. I've already got the units figured out. I've got all the data, so I'm just going to graph it. So I'm going to go Insert, Chart, and I'm going to go, once again, I'm going to go Scatter. Now I'm not going to take time to plot all of the axes labels. So, and this says mass and acceleration, so you'd probably have to play with that. But what I do want to show you is the trend line on this one. So let's take a look at that. We got a scatter chart, so that looks good. We want to customize it now. So we want to come up with that trend line, and trend line happens in the series again. So I want to click trend line, and whoa, we get this straight line, which is a nice little average of all those little data points, but it doesn't fit the curve at all. So it is not a good best fit curve. So now we're going to play around and say, well, which ones are going to give me a nice best fit curve? And sometimes it's not obvious. Like that polynomial looks pretty good. Exponential looks pretty good. So in this case, you have to use your understanding of physics to know what kind of formula there is a relationship between the mass and the acceleration. And hopefully you'll figure out that it's a power series. In other words, power could be x to the 2 power, x to the 3 power, or it could be x to the minus 1, x to the minus 2, x to the minus 3. So in this case, it's going to be the mass and the acceleration are related. They're inversely related, so it's to the negative 1 power. Now, if we look at the function and we plot the equation, check it out. 0.998, which is close to 1, times x to the minus 0.968, which is close to the minus 1. So basically, this is a 1 over x function, which, if you remember your math, that's what it looks like. It's a little 1 over x kind of curve. It's like a hyperbolic function. Okay, so you would go ahead and put the axis labels on, then you'd be ready to copy it and paste it in. Okay, that's your quick tutorial on graphing with Google Sheets. Good luck!